Bismillah Rahman Rahim. I am Sarah Khan, your instructor for the course Application of Statistics in Psychology with course code 509. This is our 17th lecture. This lecture is about the hypothesis test with the Pearson correlation. Hypothesis testing is one of the most commonly used inferential procedure. We have learned in the previous lectures the general procedure of hypothesis testing. In that lectures, we test the hypothesis about the population by drawing some sample from that population and comparing its mean. If there are two groups, then we compare the mean of the two groups and make some conclusion about the significant difference about the mean of the population and draw some inferences for the population. Now in today's lecture we will learn about the hypothesis testing with Pearson correlation. Obviously in most of the surveys or the correlational researches we take the sample from the population and get the information from that population, and from that population, using the information that we have got from that sample, we make some inferences and make some decisions or the conclusions or the inferences about that population. In the previous lecture, we have learnt about the concept of the correlation, how the correlation is about the two variables, independent or dependent variable, or x and y variable is being computed. Actually, a correlation is a statistical method used to measure and describe the relationship between two variables. A relationship exists when changes in one variable tend to be accompanied by the consistent and the predictable changes in the other variable. Okay, correlation, obviously a statistical method which is used to measure the consistency of the relationship, but it measure the relationship, describe and measure the relationship between the two variables by measuring its direction, by identifying its form and the degree. Direction of the correlation is the sign of the correlation, positive or negative. In positive correlation, two variables tend to change the same direction. As the value of x variable increases from one individual to another, the y variable also tends to increase. And when the x variable decreases, the y variable also decreases. In a negative correlation, the two variables tend to go in the opposite direction. As the x variable increases, the y variable also variable decreases. That is, it is an inverse relationship actually. And in the form of the relationship is the linear relationship. The relationship tend to have a linear form, that is, the points in the scatter plot tend to cluster around a straight line. And finally, the correlation measures the consistency of the relationship. For a linear relationship, for example, the data points can fit perfectly on the straight line. Every time x increases by 1 point, the value of y also changes by the consistent and the predictable amount. However, relationships are usually not perfect. And this consistency of the relationship is measured by the numerical value of the correlation. Perfect correlation always is identified by a correlation of 1 and indicates a perfectly consistent relationship. For a correlation of 1 or minus 1, each change in x is accompanied by a perfectly predictable change in y. And this was some information about the correlation from the previous lecture. Now we'll come to the hypothesis testing with correlation. Pearson correlation is generally computed for sample. You know, as with the most sample statistics. However, a sample correlation is often used to answer the question about the corresponding correlation. For example, a psychologist would like to know whether there is a relationship between IQ and creativity. Uh, this is a general question uh, concerning population. To answer the question, a sample would be selected and sample data would be used to compute the correlation value. Uh, Hypothesis testing is an example of inferential statistics using sample to draw inferences about the population. In the past, we have been learned using the sample means as the basis of answering the question about the population mean. In this lecture, we examine the procedure for using the sample correlation as the basis for testing hypothesis about the corresponding population. So the first step, as we have learned earlier, is stating the hypothesis. These hypotheses are about the population. The null hypothesis, as we know, stating that there is no correlation in the population or the population correlation is zero. Obviously, alternative hypothesis is the alternative of null hypothesis, stating that there is a real non-zero correlation in the population. Because the population correlation is traditionally represented by rho. This is a Greek word, rho. Uh, these hypotheses would be stated in the symbol as uh, null hypothesis, rho is equal to 0, stating that there is no population correlation. And the alternative hypothesis, rho is not equal to 0, there is a real correlation. The correlation from the sample data is used to evaluate the hypothesis. For a regular non-directional test, a sample correlation near 0 provides support for uh, null hypothesis, and the sample value far from 0 tend to refute null hypothesis. For a directional test, a positive value for the sample correlation would tend to refute a null hypothesis, stating that population correlation is not positive. If there is a specific prediction about the direction of the correlation, then we form directional hypothesis, and test will be one-tailed test. For example, if research predicting a positive relationship, if in a positive relationship, then H naught would be rho is less than and equal to 0, which means the population correlation is not positive. And the null hypothesis, alternative to the null hypothesis, each one states that rho is greater than 0. The population correlation is positive. Hypothesis tests evaluating the significance of the correlation can be conducted using either a t-test or the f-test. In this lecture, we will use t-test for the hypothesis testing of the correlation about the population. Although the sample correlation are used to test hypotheses about the population, but we should keep in mind that the sample are not expected to be identical to the population from which they come. There will be some discrepancy, there may be some sampling error between a sample statistics and the corresponding population parameter. Specifically, we always expect some error between sample correlation and the population correlation. Uh, so we focus here on the t statistics here. The t statistics for the correlation has the same general structure as the t statistics introduced in one sample or independent sample or the related to the repeated sample t-test. T-test is equal to sample statistics minus population parameter and divided it standard error. So we have some knowledge about the standard error of that set of data. The final part of the equation is the standard error, which is determined by the formula so we can calculate standard error for R is equal to standard error, which is equal to 1 minus R square divided by n minus 2 and under root of this step for the standard error. Thus, the complete statistics is R minus rho means the correlation of the sample, and the hypothesized correlation of the population, and which is to be divided by 1 minus R square divided by n minus 2. When we talk about the degree of the freedom, obviously there are two groups, two scores, x and y. So then the degree of freedom will be n minus 2. This is the data from two variables, variable x and variable y. From this data, we will compute Pearson correlation, and also is the correlation statistically significant or not. Okay, using two-tailed test with alpha 0.05. So to compute the correlation, these steps are to be followed. We have to take the square of these set of data. First of all, we will take the square of values of variable x. The first value of variable x is 8 and 64 is 25, 36, and so 36 and 20. Will also take the square of each value of the y variable. 36, 16, 0, 4 and 4. We will multiply these two variables. 8 into 6, 48, and 20, 0, 12, okay, and 10. Okay, we will take the sum of all these columns. 8 plus 5 plus 6 plus 6 and plus 5 equal to 30. It is equal to 14 and 64 plus 25 36 and 36 and plus again 25. It is 86. Okay, we put all these values in these equations. Summation x square is 86. 6 minus summation x is 30, which is to be divided by 1, 2, 3, 4, 5. It is minus 30 and divided it by 180. It's 180. Okay, and 6 is the SSX, which is the variability in independently in variable x. Then we will compute 60. So 60 minus 14 divided by 5 and 14 square. We will take the square of 14. Okay, we'll take the ये स्क्वायर और ये एक्स बार एक्स पीपीटी फाइल्स में राइट करना बहुत मुश्किल है. ओके, 60 माइनस 14 into 14 squared and divided it by 5. 32.67. 32.67 equal to now we calculate the variability which both x and y variable jointly contribute. Okay, summation xy is 90 minus summation x is 30 and summation y is 14 and it will be divided by 5. Okay, 90 minus 30, 13 into 14, 420, and divided by 5 equal to 84. 90 minus 84, and subtract this value from 90. 90 minus 84 equal to 6. Equal to 6. Okay, now we will put all these values in this equation so that we can calculate the amount of or the degree of the relationship, and also the direction of the relationship. SP is 6, which will be divided by the under root of the product of the SS of x and SS of y. 6 and SSY is 20.5, and the under root we will multiply these two 6 into 20.5 and taking the under root of this value, which is equal to 11.09. R is equal to this small r, 6 is divided by 11.09, 11.09 equal to 6 divided by 11.09, okay, which is equal to 0.54, 0.54. Okay, this is the correlation for this set of. Now we will proceed towards the steps of the hypothesis testing. The first step, stating the hypothesis. We have already discussed about the null hypothesis and the alternative hypothesis for the correlation, testing the hypothesis with respect to the correlation in the population. So correlation of the population is abbreviated with this sign, which is rho. Rho is equal to 0. It means there is no relationship, and rho is not equal to 0, which means that there is a relationship. Okay. Now in the second step we are selecting the alpha level and also locate the critical region. Alpha level is 0.05 and both hypotheses are non-directional. That's why we will use a two-tiered test. For this example, DF is 4. DF is equal to 1 minus 2, which is equal to 5 minus 2 is 3, and the degree of freedom for this set of data is 3. Alpha level is 0.05 and the two-tiered test, and the critical values for T is equal to plus minus 3.182. Here, with the help of the normal distribution, we have locate the critical region or the rejection region in the tails, and all the other region is the accepted region for the null hypothesis. This value we selected from this table. Here is the DF 1, 2, 3, this DF 3, and 0.025. We have to look this value in this column. 1, 2, 3. This is 3.182. 3.182. Okay. In the next step, we will calculate the t value. The formula for the to calculate t value is the same. Only the calculation of the standard error is to some extent different. There in the t-test, we take the difference of the means. If there is one sample t-test, the mean difference of sample and the hypothesized population mean. If the sample two independent sample t-test, then we have taken the means of the sample 1 and the sample 2 mean difference. Here we are taking the difference of correlation of the sample, and this is the correlation of the population, and we'll divide it with the standard error. We have calculated 54, I think. Yes, 0.54. We have calculated 0.54 minus 0 and divided by 1 minus 0.54 and divided by, and also the square root of this square of this value or square. And divided by n by 2. N is 5 minus 2. Alt 251. Okay. Just to complete this calculation, t is equal to 0.54. This is divided by 1 minus 0.54 into 0.54, which is equal to 0.029. 0.29. 0.29. Okay, 5 minus 2 equal to 3, and the under root of this value we will take 1 minus 0.29, which is equal to 0.71. We will divide it by 3, which is equal to 0.2366, and we will take the under root of this value, which is equal to 0.49. So 0.49. Zero 0.54, which is divided by 0.49. 0.45 divided by 0.49, which is equal to 1.10. 1.10. The value of t is 1.10. Already see either this value is located in the rejection region or the acceptance region. This value is located in this region. This is the acceptance region for null hypothesis. So we will accept the null hypothesis. So we conclude that the t value is not in the critical region. So we fail to reject the null hypothesis and conclude that the sample correlation is not large enough to reject the null hypothesis. This is activity for you. You have to calculate the Pearson correlation from this given data and also test the hypothesis. The research question is the correlation statistically significant? And you will use alpha level 0.05 and form the non-directional hypothesis. When you will form the non-directional hypothesis, you will use two-tailed test. Today we have learned the hypothesis testing with the Pearson correlation. We practically compute the t-value. Before computing the t-value, we follow the four steps for testing the hypothesis. We first state the hypothesis and select the degree, select the alpha level and identify the critical region, and after and make before going to the steps for the hypothesis testing, we compute the value of r, which is 0.54. Then step by step we follow the hypothesis testing and reach the conclusion. In all hypothesis testing procedures, whether the z-test, whether the t-test, whether the comparing the means, whether comparing the correlation, we have to proceed hypothesis testing through these four steps. If you have any question, any query, that question and the query will be handled in the class. Good luck in the class.